In the next unit, we're going to be looking at graphing points in a different coordinate system than you're used to. Everything in your math career so far has been on the rectangular coordinate plane, or an XY plane, where X's you move left and right, and then Y's you move up and down. But now we want to look at things from the perspective of a distance away from the center and an angle that we move at. So let's just do a little example here of what we're looking at. Here's my rectangular coordinate plane, and let's say I've got the point 2, 2. The way we found that is we went 2 units to the right and then 2 units up. But now there's another way that we could represent that exact point. And it's sort of referred back to what we did with vectors, where we found the idea of magnitude and a directional angle. So what we did for this is we went 2 units to the right and then 2 units up. That was rectangular. This new way we're going to look at describing points is called polar. And the way polar is going to work is we're going to go from our center and we're going to figure out a distance. How far away is the point from the center? And in terms of vectors, you know that as being the magnitude. We're then going to look at the angle measurement from 0. So this new point is going to be described as an angle measurement and a magnitude away from the center 0, 0. So that's the whole idea behind polar coordinates that we're going to be looking at. Instead of left, right, and up, down movement, we are going to be spinning, you could say, from the center in an angle direction and then walking out a certain distance, which would be the magnitude. So jumping with polar coordinates, we want to look at polar coordinates where we'll represent each point by a distance from the origin, which if you want to think about it in terms of vectors, that would be the magnitude, and an angle. So to summarize, rectangle coordinates were XY coordinates. They were also left, right, and up-down movements. And then finally, there was one unique answer. Meaning that if I saw the point 1, 3, it had to be 1 unit to the right, 3 units up. There was no other way we could get that point 1, 3. However, if we look at polar coordinates, we're going to have the format r theta, where r is going to be the radius or the distance from the center out to the point. Our movement is we are going to spin, then walk. And in other words, we are going to find our angle measurement, and then we're going to go out a certain distance. And then the final thing that's different from rectangular coordinates is that there are an infinite number of ways to write a single point. And you sort of know that idea from the unit circle. Every single time you go around the unit circle, you add 2 pi to your angle measurement, and it means the exact same angle. So it's going to be very similar with polar coordinates. So the polar coordinate system, we call point O as our starting point, and that is called the pole. We called it the origin in rectangular coordinates. That was 0, 0. The second piece that we have is the polar axis. And the polar axis is the equivalent of the x-axis that you would see in rectangular coordinates. And then finally, each point P on the plane can be represented by an r value, called the radial coordinate, and an angle measurement, called the polar angle. So radial coordinate, polar angle, is the format r, 0. So here's what we see when we look at polar coordinates. Each one of these concentric circles going out indicate a set distance away from the center. So this circle is r equals 1 for the circle, radius equals 1, radius equals 2, radius equals 3, radius equals 4. And then those cross lines indicate 45-degree angles, and then the up and down lines and left and right indicate the 90-degree angles. So from here to here is 45, from here to here is 90, from 90 over to 135, that's 45. So it's the same type of setup that you had with your rectangular system in terms of angle measurements. So we want to plot the given points. Here in polar coordinates, we've got the point 1 comma pi over 2. 1, remember, here is our radial coordinate, or the radius. The pi over 2 is the angle measurement that we are going to go. So the way that we do this is first we spin in the direction of the angle. So I look at it as if I were standing in the center and you face this east direction all the time, or the positive x direction. And then you spin in a counterclockwise direction to pi over 2. So the first thing you're going to do is measure out an angle that is pi over 2, and then you're going to go 1 unit away. So if I'm right here looking at 0 degrees, pi over 2 is straight up, and then 1 unit out is going to be right there. So 1 comma pi over 2 is the exact same thing as 0 comma 1 in rectangular coordinates. And we'll look at those conversions later, but that's really the idea that here we're going to go pi over 2 in the angle and then 1 unit out. In my second example here, I'm going to go pi over 4 for my angle and then 3 units out. So pi over 4 we know is the 45-degree angle, which is this line, and then we're going to go 1, 2, 3 units out.